Hello friends, welcome to our channel. In this video, we are going to look at problem 1007, minimum domino rotations for equal row. In this video, the data structure we are going to use is a dictionary. More specifically, we are going to use the different values 1, 2, 3, 4, 5, 6 as the key, and a set of indices as the value, right? So later you will see we are going to use set rather than simple counting of the frequency of a single number. So here I'm not going to read through the problem statement, but I want to show you the constraints. First, the length of the two lists can be as long as 2 times 10 to the power 4. Therefore, we need to think of time complexity. So these two have the same length, and the values in between 1 and 6 inclusive. So with that said, we can look at the coding. First, we are going to initialize this one, collections default dict. So I'm going to use a set, and then I'm going to iterate over this tops and bottoms. So let's say up and down in enumerate. So enumerate is for this I, right? And zip, tops and bottoms. So this is for the pair here, right? Then what we do is d up. It means the up appears at this index and down appears at this index. So you can print out this d so that you can have some feelings. For example 1, so 2 actually appears in every possible indices. Therefore, it's possible to make the row or up row or downwards row to be equal to 2, right? But for all the other numbers, it's impossible. So this is 1. So if you look at this example, you see here, though 1 appears, so let's see, 8 times. 8 is actually the same as the length of this list. However, so 1 only appears in these 6 indices. In other words, it does not appear in index 0 and index 2. Therefore, it's impossible to make a row or the up row or down row the same, right? Therefore, the return should be -1 for this case. So with that said, let's continue the logic. First, I'm going to find the largest indices, number of indices expanded. So basically, this will be a list comprehension. So we're going to get the length of item for item in d values, right? So because d values is a iterator of sets, so each set we can call the length. So this will compute for each number the possible indices it expands. So we expect this to be, we hope 1 expand all the indices. That one will be our potential equal element. This is possible that we have 2 actually expand the upper row, all the indices, but this will be some symmetry, still okay, right? So I guess you should notice this point. So with that said, let me first treat a simple case. So if this is less than the possible indices, so we are going to return -1. And then we are going to get the corresponding largest, the corresponding value or the key in the dictionary. So therefore, we'll do a comprehension for d and the key in d the items. So this let me just use this. This might be better. It's a set, right? Use a set for key and set in the items if length of the set equals m. So it's possible it has 1 or 2 elements, right? But just choose 1, any one of them. It will be fine. And then what we are going to do is to see if we make the top all equal to key, how many rotation we need, or we make the bottom equal to key, how many rotations we need. So this will be a list comprehension. So for item or value in tops, if this E does not equal to the key, right? Same thing for C2, for the bottom one. So this will be 1 for E in bottoms, right? If E does not equal to key, then what we want to return will be the minimum of C1 and C2. So this forms a complete code for this problem. Let me first run it. Yeah, it passes all the test cases here. Now let's submit that. Yeah, it passes all the cases. So here, actually, I hope that you can think a little bit deeper and improve this code. This is the one direction. Another direction is that you can write the code longer so that you can digest the finer details. For example, you can distinguish if up and down is the same. And if you have one position, the up and down are the same. So in order to make the top element or bottom element the same, you must satisfy that element. That's another perspective to think of this problem. So this also can write some short code. So with that said, I guess that's it for the current video. Thank you for watching.